This is lecture 287. In this lecture, I will try to make you understand the length of plastic hinge. What is the length of plastic hinge? This you can understand by it is the length of beam over which the moment is greater than the yield moment. If suppose ये बीम इज देयर, अगर आपकी एक बीम है जिसमें कि ये कोलेस्ट्रॉल लोड जो है 8C लग रहा है WC, जिसकी वजह से वी आर गेटिंग दिस एक्सप्लोसिव मोमेंट WC L/4 एट दिस पॉइंट वी आर लेटिंग WC L/4. So we can have the idea that at a distance of a section x, at a distance of x distance, there be only yield, and in this zone, this is the yield point, maybe yield point. This is Wy, that is My is at a distance of x from A. And this, the remaining zone is in the plastic collapse, plastic distortion. So how we'll try to find out the length, that is the length of plastic hinge. How much the length for the plastic hinge, where this plastic moment is beyond this yield stress. That is, this is in a mechanism, this is in a deformation, in a mechanism which is beyond this yield stress. So what will be the stress over here, moment over here? This will be 1 by this will be 1 by 6 BD square into Fy. This is nothing, My equal to your Fy into Z. Z equals to 1 by 6 BD square. So this is BD square by 6. So this is your 1 by 6 BD square Fy. If it is the limit, this is the limit at x. So your moment that is in stress or the My at a distance of x will be the limit. The limit of the moment will be like this. But what is the moment over here? This moment at a distance of x equal to L/2 is how much? It equals to your MP. MP is how much? That is 1 by 4 BD square into Fy. So at this point you can proportionate this and lengthen this length. So you take this length. If you take this length, this moment, that is 1 by 6, that is My by MP, you can say. So this My by MP is equal to 1 by 6 BD square into Fy. And what is this? This is 1 by 4 BD square into Fy. But the relation is how much from this diagram? This distance is x. So this is equals to x divided by L/2. Because this distance is L/2 and this is x. So the ratio of these two moment will be equal to x divided by L/2. We want to know the distance. What is the distance between these 2 points? What is the hinge length? What is the plastic hinge length? That we want to calculate over here. So what will be the length? You may have 2x by L equals to your 1/6 BD square. BD you can simplify. This is 1 by 6 multiplied by 4. So this will be your 2 by 3. So x equals to 2 by 3 L divided by 2. So this is your L/3. So this distance up to which the yield stress exists, and beyond that this plastic deformation is going. So this is your distance is L/3. So this side is distance is L/3. So middle 2/3 will be in the hinge length. 2L/3 is this distance. This is 2L/3. So 2L/3 here, 2L/3 this L/3 that is L/3 is the length of the yield stress. So this span is under this plastic hinge. So plastic hinge length, you can say from A point at L/3, from B point at it is L/2. third, or this middle 2/3 of the L equals to your plastic hinge. So it is the length of beam over which the moment is greater than the yield moment. So these are the points. These are points. So this length is 2L by 3. So plastic hinge length will be your 2L by 3. Yeah, from A this lies at a distance of L by 3 from A. Yeah, from B it lies at a distance of L by 3. So 2/3 L by L3 is your plastic length of the hinge. In this way we can calculate the plastic hinge for different loading. So we'll try to go for that, or we tabulate it in the form so that you can remember. So thank you for being with me. Thank you very much.